Hey guys, how's everyone doing? This is Mr. Chavla, and today I'm going to be going over the June 2016 Common Core Algebra 2 exam. So again, this is Mr. Chavla or Mr. C, and this will be my key, and I'm going to see if I could go over numbers 1 through 6 at the minimum, and if I could go through 1 through 8, even better. But let's get started right away. So number 1, when b is greater than 0, just trying to find a good spot for me. So when b is greater than 0, b is positive, and d is also positive integer. The expression 3b to the t over d power is equivalent to. So guys, where you see all the choices 1 through 4 are in radical form, and we have a rational exponent in the question. So in order to convert into radical form, the base 3b, which I'll keep in parentheses because they put in parentheses, will go inside a radical symbol. The denominator d will end up going in the index, and then the 2 will go in the exponent. Now if we check, the first choice has 1 in the numerator, and so does the choice 3, so those are no good. And choice 2 is missing it has the d in the exponent instead of in the root. So by elimination, we know we have choice 4. But the other way we could represent this is it's the same thing as if we have the 3b in the root, and then we square the whole thing. So that's what we got for choice 4. All right, so that's about converting between radical form and rational exponents. Now let's look at number 2. Julie averaged 85 on the first 3 tests of the semester in her math class. Not bad at all. If she scores 93 on each of the remaining tests, her average will be 90. Which equation could be used to determine how many tests T are left in the semester? So if she scored 85, if she averaged an 85 on the first 3 tests, the sum of the first 3 exams will just be 85 times 3. And then, because if she got an 8, let's say she got 85 on each of the first 3 exams, then it'll still be 85 plus 85, right? Then she scored 93 on each of the remaining tests, and they say T is the number of tests remaining. So we multiply 93 by T. So for example, if it's one test, 93 times 1 is 93 is the sum of her scores on the remaining exams. If there were 2 exams and she scored 93 on each, the sum will be 93 times 2. So if it's T, it's 93T, 93T. So, and then the average would be 90 in that case. So we know it's going to equal 90. So the total sum of the first 3 exams, which is 85 times 3, plus the next T exams, which is 93, it all divided by the number of exams. So remember, the first one, there were 3 exams, then plus T exams. So the total number of exams is 3 plus T, or T plus 3. These two choices have T plus 3 in the denominator. These two have 3T, so we're down to 50-50. We know that 85 times 3 has to be 255. We don't need to show that work because all the choices put 255 up here. But the average has to be 90 and not 93, so it'll be choice 3. Because this could be rewritten as 255 in place of the 85 times 3, plus 93t, and then by the commutative property, 3 plus t or t plus 3 is the same thing. T plus 3 is the number of exams. I'm putting parentheses just to group them together. And then 255 plus 3t is the sum of all exam scores. I'll just say sum of exams. So sum divided by the total number is the average, which is 90. AVG. All right, so the answer is choice 3. Now I'm going to go on to question 3, all right? And I'm trying to go, if I'm going a little too fast, I apologize. The last time I tried to upload the video to YouTube, they said that my videos were too long, so I'm trying to kind of get this in. And if it is too fast, let me know, and I'll make another video a little shorter. So I'm erasing this. Rewind if you need to, because I want to go to number 3. The imaginary unit 2 minus yi squared in simplest form is, so guys, if you know the shortcut for squaring a binomial, that's better than, but I'll actually multiply it by itself. So first I'm going to distribute this 2 times 2 minus yi. Then I'm going to distribute the negative yi times the second binomial again, which is 2 minus yi. So I just distributed each of the first terms by the second binomial. All right, so if you want to see that, this was the 2 being distributed, and then I distributed the negative yi right here, and both of them are being distributed over the original over the second binomial, the entire 2 minus yi, which will show up twice here. So if I distribute carefully, I'll have no issue. I distribute 2, I get 4 minus 2yi. I distribute negative yi, I get negative 2yi again. Now careful, when I multiply two negatives, it becomes positive, and I got to square both the y and the I. Now remember, I square is equal to negative 1. So this becomes plus y square times negative 1, which ultimately becomes negative y square. Now if I bring down these two like terms, combine to make negative 4yi, and I bring down the 4, and then if I reverse the order and write it in standard form, I get negative y square minus 4yi, and then the last 4 is positive. So it's got to be choice 2, negative y squared minus 4yi plus 4. So that's choice 2. Okay, and you could also do a shortcut, but if you know how to do it, it'll be easier when you're squaring a binomial. Okay, moving on. Question 4. So this one wasn't hard at all either. Let's go ahead and take a look at it. So it said, which graph has the following characteristics? So which of the 4 graphs provided satisfies all three criteria? So we start off with, it has to have 3 real zeros. That's the same as saying it has to have 3 x-intercepts. So I'm gonna label that in blue. So it has to have 3 of them. The next one is saying that as x approaches negative infinity, y also approaches negative infinity, because that's what f of x is. What that means is that I have to have a graph. First of all, there should be 3 x-intercepts. I guess I said I'd use blue for that. So let me get a blue marker. Okay, so blue. So it doesn't matter where the x-intercepts are, but there need to be 3 of them. Now, the next thing, as x approaches negative infinity, and I'm going to use yellow, hopefully it'll show, that means as x is decreasing, meaning we're moving to the left on the x-axis, the y value is also going down. As x approaches negative infinity, y also approaches negative infinity. Then the next part, I'm going to highlight in pink. Why not? As x approaches positive infinity, meaning as x is increasing, y is also increasing. And I'll just mark that with red. So that means on the other end, as x increases towards infinity, on the x-axis, y also increases. So the tail ends are pointing this way, and then our graph should look something like this. I'll use just black for the graph. So I'm not going to change. So if I trace over this, it should look something of this sort, with our 3 x-intercepts, and then as x increases to infinity, y increases to infinity, and as x decreases to negative infinity, y decreases to negative infinity. So if we look at this one, the tail end is pointing upwards from the left. This means that as x is going to negative infinity, y is actually approaching positive infinity. So just based on that, this is out. This one, we see the tail end pointing down. As x is decreasing, y is going down. So that's good. That satisfies this second criteria. The third one, as x approaches infinity, as x is increasing, so is y. We got that part. And then we got 3 x-intercepts. 1, 2, 3. So choice 3 is our answer beyond a shadow of a doubt. And the tail ends, the arrows on the graph should be pointing in the opposite direction. If we look at choice 2 and 4, they're both pointing in the same direction. They're both increasing regardless of whether x is increasing or decreasing as their end behavior. All right, so those two are clearly out as well. All right, so that was question 4. You just need to know how to determine the zeros or the x-intercepts. And you need to know that how to recognize end behavior. Okay, so let's move along to question 5. We're actually making good progress. I might be able to get all 8 questions in. And again, if you feel like I'm going too fast, let me know, and I'll just redo the video and go a little slower, or make another version. So the solution of the equation square root of 56 minus x equals x is, guys, this is a multiple choice question, and they're giving you some choices. This means there's no solution. So what I'm going to do is, let's just go into the graphing calculator and just go to table. Right? I love my Desmos. It's free, and I don't have to download anything. But your calculator should have a graph and a table feature, right? And sometimes you could put both in together. So since one of the y values is just x, why don't I just say that y1 is equal to the square root of, it was 56 minus x? Yes, it was. All right, you don't need the parentheses, but they put it there. I didn't feel like taking it out. And then instead, why don't we just make a table? And one of the x values will be for y1, and the other one for y2. So remember, one of them was for 56 minus x. The other one was just when is it equal to x. So this is, I'm setting this equal to y1, the entire expression, and the other one equal to y2. And wherever we get the same answer for both, that's going to be our solution, if there is one. And I'm only going to put the numbers that they put, right? So one of them was -8. When x is -8, y1, which is the square root of 56 minus x, did not give me 8. These two, the values in these two columns are not the same. I got +8 instead of the same x value of -8. So anything with -8 is out, and I can already eliminate choice 1. I'm going to check for now -7. -7 didn't work either, so that eliminates choice 2. So now I want to see if +7 works. +7 does indeed work, because an input of 7, when you substitute into 56 minus x, you get 7 again. And when y2 equals x, well, that just gives the original input of 7. So since they're equal when x equals 7, we can't say there's no solution. The answer is choice 3. The solution set is only 7. Okay? Pause the video if you need to. It's also important to know how to solve these equations algebraically. So what I'm going to do now is I'm going to go. I'm sorry, my throat just got clogged. I'm gonna go over to the smartboard, or actually, I'm not gonna do that because I could. Yes, I will, and I'm gonna solve it algebraically now. All right, so I'm gonna just open a blank page, and I need to solve for the square root of 56 minus x is just equal to x. So if I do that, perfect. So square root of 56 minus x is just equal to x. How do I get rid of the square root sign, guys? I gotta square both sides. Square them both. Whatever you do to one side has to be done to both sides. And then, when you square a square root symbol, the two cancel out. They're inverse operations. So all that's left on the left-hand side is 56 minus x, and x, when you square it, is just x squared. Now I'm going to add x to both sides, and I'm going to subtract 56, and there are no like terms. So if I write this in standard form, I get x squared plus x minus 56. And I'm going to just solve this by factoring to solve for which value of x gives me 0. If I want to factor, I want two numbers that have a sum or difference of 1 and multiply to -56. And if you work that out, you get x plus 8 and x minus 7 equals 0. And when you solve x plus 8 equals 0, you'll get x equals -8. And if you solve x minus 7 equals 0, you get x equals 7. But then you have to substitute into the original equation to see if they work, because what could happen in this squaring step is you could end up with what are called extraneous roots that don't work for the original equation. So I'm going to go back to the original equation now, and I'm going to substitute. So the original equation was 56 minus x. So when x equals -8, I'm going to substitute -8. So 56 minus -8, which is x, is equal to x, -8. Unless you have a plus minus in front of here, a square root cannot be it cannot be a negative number. The only time is if you have a plus, minus, or if you have a negative in front of the square root, then it's negative. But if you just take square root, the lowest you could get when you take the square root is 0. So already we know this won't work. And if you do 56 minus -8, that's 56 plus 8 is 64. The square root of 64 is 8, which is not the same as -8. So that, sorry, I was just checking my phone. So x equals -8 is rejected. So we cannot accept this solution because it's extraneous. So we're going to check 56. Remember, it was 56 minus x. So I substitute 7 for x equals x, which is 7. Square root of 56 minus 7 is the square root of 49. And not the square root, is just equal to 7. And we get 7 equals 7. So our solution is x equals 7, just like we saw before. All right. Pause the video, rewind if you need to. I hope I'm not going too fast, but here's the work. All right. We just squared both sides, set it equal to 0, factored, and then we check for extraneous roots. And honestly, I would have just used the calculator for this one if it's multiple choice. Let's move along. And it's still x equals 7 only, choice 3. Now, same thing goes for number 6. We could do this algebraically, or we could use our calculator. We could use a graphing calculator. They want us to find the zeros of f of x, where f of x is this equation. I'm just going to use, there's a polynomial equation solver. That's the best way to go about it, I think. But even if not, here's what I'm going to do. Let's just see which values are the x-intercepts, because those are the ones that give an output of 0. And I'll even change this to f of x, because we could do it in this calculator, which I didn't know at first. I'm going to get rid of this column. And I want to just have f of x here. I could have put y. I know most calculators don't allow you to do that. So x to the 4th minus 4x cubed minus 9x squared plus 36x, I believe. Yes. And we are going to just look for the zeros. So all of them are giving 0 as an option. And yes, if you substitute x for 0, all these terms will become 0 when you multiply x by anything. Now let's try 3 and negative 3 from choice 1. 3 gives us 0. Negative 3 gives us 0. 4 gives us 0. So that looks like choice 1. Negative 4 does not give us 0. No other options were given. It was 0, positive and negative 3, and then positive negative 4 were the choices. So that already looks like it's going to be choice 1. And we could confirm using the x-intercepts of the graph. The x-intercepts are at, and I'm only looking for where it crosses the x-axis, and we get those three numbers. So that's 0, positive negative 3, and 4. So 0, positive negative 3, and 4. That's choice 1, and we can move on, right? If you wanted to do it algebraically, here's how you would do it. Okay, so I'm going to write the equation. The first step is, I mean, there are a few ways to do this. The first step would be to factor out the entire GCF. You could factor by grouping first, but that's a little extra work. So I'm going to factor the entire GCF, which is x. Then in parentheses or brackets, I'm going to get x cubed minus 4x squared. I'm going to change color, and you'll see why in a second. Minus 9x squared plus minus 9x. Plus 36. All right, and we want everything to equal 0. So now here's what we're going to do. This x, we already know this will end up giving us x equals 0, right? Because that's a lone factor. If you set it equal to 0, it's just 0. If I factor this part, the GCF is x squared, and we get x minus 4 in parentheses. Then the blue, the GCF is negative 9 because of this leading coefficient. I don't like the way that came out looking. And then in parentheses, we got to change the sign, so it's positive x minus 4 equals 0. Then our x minus 4 is a GCF, so we bring that down here. Then we look at this x squared minus 9 will be grouped together here. And if I want all the zeros together, I'll also bring down this original x, which I didn't bring down here because I was only grouping these two parts. So now I could solve either using inverse operations, or I could further factor the difference of squares here. It becomes x plus 3 and x minus 3 and x minus 4 equals 0. So x equals 0. There's nothing left to solve. X plus 3 equals 0 results in x equals negative 3. X minus 3 equals 0 results in x equals positive 3. And x minus 4 equals 0 results in x equals 4. These two, the two negative 3 and 3 can combine to become plus minus 3. Right? 0 was the first one, and then the last one was 4. And that's how we got choice 1, guys. All right? So I think we have space and time for me to go over number 7 and 8. So I'm changing the key. This is the key now for numbers 1 through 8. Okay, pause the video if you need to. I know I'm kind of zipping by kind of quick, but that's because I don't want to get rejected again. I spend a lot of time making these videos, and I want you guys to see them. And I don't like being rejected by YouTube. That's very sad. Okay, so take a screenshot, do what you got to do. I'm going to erase everything now so I have space for the next question. Okay, now that I did that, let me clear everything off. Okay, next thing. Anne has a coin. Well, good for her. What about it? She doesn't know if it's a fair coin. A fair coin means there should be equal chance of landing on heads or tails. She flipped the coin 100 times. Okay, got nothing better to do. And she got 73 heads and 27 tails. Okay, so let's just note that. So Anne got 73 heads. I'll put H, and 27 tails out of 100 flips. So it's 73% heads, 27% tails. She ran a computer simulation of 200 samples of 100 fair coin flips. So if you look at the dots below, the output of the proportion of heads is shown below. I'm just continue using the highlighter because otherwise I end up crossing stuff out. She ran a computer simulation of 200 samples of 100 fair coin flips. Okay, the 200 samples, if you look, and the output of proportion of heads is shown below. So the output is giving a proportion of heads. Each dot represents 100 flips of a fair coin, meaning that there should be an equal chance of getting heads or tails, 50%. Um, each dot represents 100 flips. That's one simulation or one sample, right? She took 200 samples, so there are 200 of these dots. If you look carefully, this follows, and it should follow an approximately normal distribution, a normal distribution curve. So given the results of our coin flips and of our computer simulation, which statement is most accurate? Well, first thing, if you look at, we don't care about the samples right now, but we do look at the mean. This is 49.7%, 0.497, which is very close to 50%, which is to be expected, and this is the standard deviation. First thing we want to do is let's read the choices first before I jump ahead of myself. 73 of the computer's next 100 coin flips will be heads. The highest number of heads, because these are going by, this is 40 heads, 41, 42, 43, 44, 45. We got 60 and 61. That is very unlikely because the computer never got more than 61 heads. The lowest was 35 heads, which is 35% or 0.35, to the maximum, which was 0.61 heads. So anything more than 60 heads, we don't expect the computer to do that. And it's a fair coin. 50 over 100 next coin flips will be heads. How could you possibly know that? But we'll leave that for now. Her coin is fair or not fair. Okay, so guys, if in a fair coin flip simulation, you never got you got the highest you could get is 61%, you never got 73% in the you never got 73%, which would be like way over here somewhere, right? This would be like 0.65, 0.70, 0.75, right? 0.73 would be somewhere here. That we never got above 0.61 in the fair coin flip simulation. So we do not at all expect choice 1 to happen for a fair coin, and that means her coin is not fair because she got something that we really don't expect from a fair coin based on the simulation. Because remember, it's based on the simulation. So that eliminates choice 4. 50 of our next 100 coin flips will be heads. We, first of all, wouldn't know. We can't really predict that. And it's unlikely because her coin is not fair. So our answer is choice 3. That was one way to look at it. Now, pause the video because I'm going to go over one other part of this problem. I'm going to erase this. And the other thing you could look at, guys, what if it's a normal distribution? They didn't say it, but you could see it, the shape of the graph. If you take the mean plus and minus 2 standard deviations, the mean is 0.497. So it's going to be 0.497 plus minus 2 times the standard deviation, which is 0.05. We're 95% confident that when we flip so it's 95% confidence, right? We're 95% confident that the number of flips, the proportion of heads we obtain will be somewhere in this interval. So if you put it in the calculator, 2 times 0.05 is just 0.10. So 0.497 minus that will give you 0.397. And then the upper bound, when we add 0.1, will be 0.597. This corresponds to about 40 heads. And this corresponds to about 60 heads, right? Because you can't have 39.7 heads out of 100. So we expect 95% of the time, we expect to get between 40 and 60 heads. Anything outside that range, then we have reason to suspect the coin is not fair. 73 heads or 0.73 is definitely outside that range. So her coin is not fair. Had she gotten, let's say, 55 heads, 45 heads, even 42 heads, we could say it's fair. But 73, that is obviously not fair. Not fair. Okay? We're going to go move on now to the last, and this is about sample proportions. Okay? And knowing about your 95% confidence intervals, and maybe even a little bit about understanding what a fair coin is, because that could show up. Now, number 8. If g of c is equal to 1 minus c squared and m of c is equal to c plus 1, which statement is not true? I'm going to go through them one by one, and then we're going to find out which one's not true, okay? So g of c times m of c, that means we're taking 1 minus c squared times c plus 1. I'm going to distribute the 1, but multiplying anything by 1 just gives you the same original polynomial. And then we are distributing the negative c squared. So if I multiply negative c squared times c, I get negative c cubed. And if I multiply negative c squared by 1, I get negative c squared. Now let's look at this choice. Is this expression equal to the one we got? Well, c plus 1, we could switch the order, commutative property, and get 1 plus c. And when we're subtracting two terms, it doesn't matter the order in which I subtract them. So these could also switch. So that's fine. Like, subtraction is not commutative in the sense that 2 minus 5 and 5 minus 2 are not the same. But if I do negative 2 minus 5 and negative 5 minus 2, they're the same thing. They're both equal to negative 7. So if they're both negative, that's fine. So 1 plus c minus c squared minus c cubed, I guess in like opposite, in reverse standard form. So they say which one's not true. This is true. So we're going to take it out. All right. Pause the video if you need to. I'm going to go to the next one, option 2, choice 2, to see if that's true or not. And we could have used the calculator, but I'll skip that part for now because we should be able to do this. So g of c is 1 minus c squared. So for option 2, choice 2, g of c plus m of c, which is c plus 1, they're saying it's equal to this expression. I'm going to simplify this. First of all, we don't need the parentheses. My like terms, 1 plus 1 is 2. And then I get 2 minus c squared plus c, which is the same again if I switch the order and get 2 plus c minus c squared. That's what we got right here, 2 plus c minus c squared, so that's correct. And remember, we want to know which one's not correct. So, pause the video. I'm going to see choice 3 and see if we could find something that doesn't work. So, m of c minus g of c. So, m of c is c plus 1. And again, this is for choice 3. Minus g of c. I must use the parentheses here. Minus 1 minus c squared. Ignore this for now. I keep the first binomial the same. It's like distributing a negative 1 over these two, and the sign just changes. So it's minus 1 plus c squared. 1 minus 1 cancels out to be 0. So I get c plus 0 plus c squared. I don't need to write 0. C plus c squared, that's correct. And by elimination, I know my answer has to be choice 4. And here's how, and let's just prove it algebraically once. All right, pause the video if you need to. I apologize if I'm going too fast. Let's show that option 4 is the choice algebraically. So m of c is c plus 1 over g of c, which is 1 minus c squared. That ends up being equal to c plus 1 over, this is about simplifying rational expressions. This is a difference of squares, factors into 1 minus c and 1 plus c. That was a mess. I'm sorry. Let me put that back. Okay, and 1 plus c. And I'll also put the c plus 1 in parentheses. Now, this c plus 1 and 1 plus c by the commutative property are equal to each other. So they're simply going to cancel out to give you a quotient of 1. So it becomes 1 over 1 minus c, not negative 1 over 1 minus c. So the answer is indeed choice 4. The only way you would have gotten negative 1 is if you subtract in the opposite order. So if you have 1 minus c over c minus 1, these two would cancel to become negative 1. Because this is equal to negative 1. Let me erase this for a second. Pause the video again if you need to. Because this is equal to negative 1 times c minus 1. When you reverse the order, if you distribute this, you get negative c plus 1, which is the same as 1 minus c. All right? So that's why if you take this, divide it by c minus 1, these cancel, you get negative 1. So next time you know that anytime you have b minus a over a minus b, you get negative 1. But if you have a plus b over b plus a, that's just equal to positive 1. All right? So that was it, guys, for questions 1 through 8. I'm about to start questions 9 through 16 very shortly. Thanks for stopping by. Best of luck. Let me know if you have any questions, comments, concerns. I'm here. If you enjoyed the video, please hit like, subscribe. I'd appreciate that very much. Best of luck, guys. See you soon.